Greetings and welcome to this video lectures on develop and implementation of a retrieval-based placement chatbot using natural language processing techniques. This is Dr.R.Usharani, Assistant Professor, Department of Computational Intelligence, SRM Institute of Science and Technology, Katanglatur. So in this lecture, we will learn how chatbots work under the natural language processing concepts such as term frequency, inverse document frequency, cosine similarity, bigram and stemming, and finally develop a retrieval-based placement chatbot using Python. Before building a chatbot, we must first understand what a chatbot actually is and where it is used. These are all the learning objectives. By end of this session, we will be able to understand information retrieval technique, apply term frequency, inverse document frequency, and cosine similarity, and develop a retrieval-based placement chatbot. Let's begin with the basic concepts of chatbot. A chatbot is a software application that simulates human conversation by interacting with users through text or voice and providing appropriate responses. Why chatbots are used? Chatbots help users obtain information quickly without human intervention. So there are many application areas using this chatbot, uh, like education, banking sectors, e-commerce, and healthcare sectors. In education, assisting students with administrative duties, giving advice on courses, course selections, eligibility criteria, and so on. While banking chatbot, it providing account information, helping customers with the transactions in real time. Similarly, in e-commerce, providing 24 bar 7 customer support, guiding users through purchasing processes, etc. While in healthcare sector, supporting patient monitoring through routine checkup, scheduling appointment, and offering health information. Hope you understand chatbot better. Let's look at a simple example. So if the user raises a query, what's the placement eligibility? It collects the input from the user and processes the user's request, identify the context and sentiment. Later on, compose a reply accordingly. The reply is students with the CGPA above 7 are eligible is an example answer for the stored question. This is how an AI chatbot works. There are many advantages: 24 bar 7 availability, quick responses, and reduces human efforts. And limitations are it may not understand complex questions, depend on available knowledge. It can provide incorrect responses also possible. So different types of chatbots are available. The major categories are rule-based chatbot, retrieval-based chatbot, and generative chatbot. So in rule-based chatbot uses predefined rules. For example, if the user asks hello, then immediately the bot replies in a greeting message, hi, welcome, like this. So it is easy to implement but cannot handle questions outside its rules. So the chatbot in generative chatbot generates new responses using AI models. Examples are ChatGPT, Gemini, Claude. On the other hand, in contrast with the retrieval-based chatbot, mm, it cannot handle uh, s- new generative responses, or it cannot generates new responses, um, but it chooses the most relevant answer from the stored question and the answers in the database. For example, if the student or user asks a query placement eligibility in the database containing several questions, let us assume what is the placement eligibility criteria, the question also available in the database. Then the word placement eligibility, check it out with this stored question whether the scoring criteria is high, then the relevant answers retrieved from the database. Students with the CGPA above 7 are eligible. So the Chatbot developed in this lecture belong to the retrieval based category. So let's understand how retrieval works. So there are many types of techniques we can implement retrieval based chatbot types. Term frequency with the inverse document frequency along with cosine similarity, word to vector, document to vector, sentence transformers, word embedding, and vector database search. So in this uh, video, we are going to implement a retrieval based chatbot using term frequency, inverse document frequency with cosine similarity. So assume you have a database containing some of the placement related question and answers. If the user asks any questions, the user enters the question in natural language. The query after that collected by the next level text processing has been done. Let us assume removing punctuation marks, stop words, and extra spaces. After text pre-processing, next we need to implement with term frequency and inverse document vectorization. So after that, it uses the cosine similarity. Next, it find out the best matching question from the database, retrieve the question and the relevant answers from the database, and it responds answers to the user query. So this is how our working of retrieval based chatbot using term frequency, inverse document frequency with cosine similarity. But how does the chatbot determine in which question is the closest matching? For that, we need to understand term frequency and inverse document frequency and cosine similarity working principles. So let us uh, start with this example. Stored question databases. What is placement eligibility criteria? What is the highest package offered? Are internships mandatory? The relevant answers are also stored in the databases. Students with the CGPA above 7 are eligible. Highest package offered was 18 LPA. And are internships mandatory? The relevant answer is yes, internships are mandatory. So whenever the user raising the query, tell me about the eligibility for placement, the relevant answers with the CGPA above 7 are eligible can be retrieved from the stored answer. But how it is possible? So we need the prerequisite term frequency, inverse document frequency, and how to combine term frequency with the IDF and cosine similarity with vector representation. So let's begin with the term frequency. The term frequency measures how often a word appears in a document or sentence. The formula used here is number of times term T appears in document D divided by total words in a document D. Let us consider an example. Mm, The sentence contains placement training program. The total words are 4. Count of word placement equal to 2. So the calculation here is count of word placement, the word placement count is 2 divided by total words 4. So the term frequency of the word placement equal to zero point 0.5. It gives us the word placement occupies 50 percentage of the sentence. Next we can move with inverse document frequency. It measures how important a word is across all documents. Suppose the words appearing in many documents are less important. Suppose the words appearing in only a few documents are more important. For consider the example, there are three documents: document 1, document 2, and document 3. Document 1 contains the sentence placement eligibility criteria. Document 2 contains the sentence highest package offered, and document 3 contains the sentence placement training program. So there are totally three documents we have, therefore n equal to 3. So now the user is raising the query placement eligibility. How it will work using IDF. First find the IDF of the word placement. The word appears in the document 1 and document 3 two times. Therefore, document frequency equal to 2. Here inverse document frequency formula is logarithm of n divided by document frequency. So now logarithm of 3 divided by 2. So the answer is 0.176. Since placement, the word placement appears in multiple documents, its importance decreases. The other word, find inverse document frequency of eligibility. It appears only in the document 1. So document frequency equal to 1. The idea formula is logarithm of total n3 divided by document frequency 1. Therefore, the IDF answer of the word eligibility equal to 0.477. Since it appears in only one document, it is more important. So, um, but how does the chatbot determine which question is the closest match for that? We need to understand the cosine similarity. Before then, that just we combine um, local importance and global importance. That is nothing but term frequency into inverse document frequency. So the answer is 0.088. Next, the cosine similarity. It measures how similar two text documents are. So here the it compares cannot understand text directly. Therefore, we convert text into vectors. The cosine similarity measures the angle between two vectors and determine how similar they are. So, after understanding this workflow, we can implement the chatbot using Python is possible. So the vector representation is nothing but, let us consider the stored question placement eligibility criteria. User is raising the query placement eligibility, two words. So the vocabulary from the stored questions are placement, eligibility, next word criteria. There are three words. Okay, each and every word is unique. Therefore, the stored question vector is 111 and the user query is 110 here. The formula of cosine similarity A comma B equal to A dot product B divided by magnitude of A into magnitude of B. So how do we calculate the dot matrix? That is, already we have the vector from the stored document, unique words vocabulary 111, and then user raising the query, that vector is 110. So multiply this with 1 into 1, that is the first all the triple ones indicated the stored question 111, and the remaining right hand side question 110 is a user raised placement eligibility, the two word 1 1, and then remaining one is 0. This is equal to 2. Next step, magnitude of A need to calculate here. So the root of all the stored question values squared up here, root of 1 square plus 1 square plus 1 square, then we can get root 3. Similarly, we need to calculate magnitude of B. The user raising query placement eligibility 1 1, remaining there is no other word here, so remaining one is 0. So root of 1 squared plus 1 squared plus 0 squared, which is equal to 2. So next, how do we measure the similarity using the formula cosine similarity? Here, the cosine similarity of A comma B equal to the dot product A into B answer is 2 divided by, and then magnitude of A answer is root 3 into magnitude of B answer is root 2. So now the result is 0.816. Though so the similarity score equal to 0.816. Otherwise, we can say that 81.6 percentage. So using term frequency, inverse document frequency vectorizer, and cosine similarity, after understanding all these things, we can implement uh, this with Python program is possible. So connection to the chatbot, when a user enters tell me the placement eligibility, the chatbot performs these steps: convert all stored questions into term frequency and IDF vectors, convert user query into term frequency and IDF vector. Next step, compute cosine similarity between the query and every stored question. Next, choose the question with the highest similarity score. It returns the corresponding answer. So how do we implement it with Python? So look at the Python programming. Later I will run the same program in our Google Colab environment. First look at this code. Here we need to import necessary libraries, pandas, and the scikit-learn and the feature extraction technique with the TF-IDF vectorizer, that is term frequency, inverse document frequency vectorizer, similarly others. Next, we need to create a data set. First, I am creating the data with question. Set of questions are available here. What is the placement eligibility criteria? How many companies visited last year? What's the highest package offered? What's the average package offered? Similarly, some other questions. The relevant answer also showed in this data answer equal to students with the CGPA above 7 are eligible. Around 120 companies visited our campus. Highest package offered was 18 LPA. Similarly, all other answers. All the question and answers are stored in this data. Now we need to convert the data into data frame for further process. So the data frame, the pandas object PD dot data frame of add the data question and answer to in this data frame DF here. So after that, we need to introduce a vectorizer. So term frequency, inverse document frequency vectorizer functions used here. Then after that, the question vectorized to fit transform function. And the next, whether the question is available in this stored database, then we need to check it out. After that, cosine similarity introduced. So the cosine similarity score is high. For example, if score is greater than zero point 0.2, it will print the relevant answer from the database with similarity score. Otherwise, the score is less than 2.2, then the bot replies to the user, sorry, I do not have information about that. So, first, I will run this program in Google Colab environment. So this is my first program. Here, whatever code we already discussed in the PPT, just the same code utilized here, question with answer. After that, data data set the question and answer added to the data frame for further usage. Then we are introducing the term frequency IDF vectorization using this method. Then after that, vectorization transform functions enabled here. After that, while the query is available or not, we need to check it out. Next, we need to enter the cosine similarity, score, and similarity score also displayed on the screen, and answer if the score is high, that is greater than zero point 0.2, fetched from the database, and the relevant answer also displayed on the score with the similarity score. Else it will print, sorry, I do not have the information about that. So look at the input and output. Once again, I will run again for your understanding purpose. Just the stored question and answer available here. So the placement chatbot ready to type exit to stop. So now the input is placement eligibility, that the user raising this question placement eligibility. So the bot replies from the answer, relevant answer is available in the data set or not, it will check it out. So the relevant answer is there, students with CGPA above 7 are eligible. So now the similarity score is 0.611. So next I am raising the same question with the different type. What is the CGPA eligibility score? Here also the same answer displaying here. Now the similarity score is increased. Okay, so because the word CGPA eligibility score, three words are available in the stored question, therefore similarity score is high. Next I am asking the same question, placement starting month. Now placement is available in document 1 and document 3, we have already seen, but the word start is available, but starting this word and the month is not available. Therefore, it will give us a wrong result. Students with the CGPA above 7 are eligible. The similarity score is very low now. And when is the placement starting? Here also, it does not give us a relevant answer. The students with the CGPA above 7 are eligible is not correct answer, because the question not correctly related to the stored questions. So similarly, When is the placement start? Actually, the when is the placement start? The placement and then start. These two words are available in the previous question. When do placement starts here? So placement and start. These two words are available. So the relevant answer now the chatbot replies placement generally start in July. Okay. So now the answer is correct. So how do we understand this is irrelevant answer also? This irrelevant answer also displayed na. So how do we rectify these issues? So then we can introduce another two techniques, bigram and stemming techniques in the same program. So what is bigram and stemming techniques? Let us consider this. An n-gram is a way of breaking text into continuous sequences of n words. So there are types of n-grams are available. Unigram, bigram, trigram. Unigram means single word, bigram means two consecutive words, and trigram means three consecutives. What are all they? Consider an example. The sentence placement eligibility criteria. This is a user raised question, let us assume. So now the sentence can be breaking into text unique single words. Placement is a single word, eligibility is a single word, criteria is another single word. On the other hand, bigram means we can take two words from the sentence. Placement, eligibility, these two words, that is bigram, two consecutive words. Another consecutive two words, eligibility criteria. This is known as bigram. Similarly, we can take placement, eligibility criteria, trigrams as a one three consecutive words as one, it is also possible. So why n-grams are used? It capture word relationships, improve meaning and understanding compared to single words, and help in better matching in chatbot search systems. So uh, in our program we are going to implement stemming also. So what is stemming? It's a rule based process that chops off prefixes and suffixes to get a root form of a word. For example, running. From this word, the suffix ing can be removed. So we can take only the word run. Similarly, studies. Now es removed, suffix these two letters removed. Now study. And caring. ing removed car. But in the stemming, study and car are not proper dictionary words. uh, Even though we can use this stemming is possible for small amount of database with the question and answer are possible, therefore we are going to implement this stemming. So common stemmer, porter stemmer, we are going to implement. On the other hand, we can use lemmatization also. It uses vocabulary plus grammar to get the correct base form called lemma. So it always produces a meaningful word. So it consider context and part of speech. It's slower but more accurate. For example, running can be that is the suffixes ing removed from this word, then we can get run. Studies, look at and compare this with the previous stemming process. Here the lemmatization studies, the suffix ies removed, but it can be give the meaningful word study study. Similarly, better it can be transformed into good. First we will implement the stemming and bigram into our previous program. Then watch the results. So this is retrieval based placement chatbot using term frequency, inverse document frequency, Porter summer, bigram and cosine similarity. So similarly, we are using the necessary toolkits, and after that text pre-processing used with stemmer. So Porter stemmer we are using here. After that we convert all the text into lowercase. Next, we can remove the punctuation using this. Remove with the substring of what are all the word available in the sentence. Then we can uh, take it into account, and the word split can be doing here. Then after that, the data set. Similarly, we have seen already the same question with answer with the data, and it can be added with the data frame. Next, the same term frequency IDF vectorization doing here, but here we are doing the n-gram range equal to 1 comma 2, which means unigram plus bigram together we are using here. After that, the vectorizer fit transform with that question. Now the placement chatbot ready to run and gives the answer. Now the input is placement starting date. The previously we are using placement starting date is an input. Look at here, placement starting date or month, but it does not give the proper answer because the suffixes are not removed and it cannot understand the relevant question from the stored database. But now we are doing the port stemmer. Therefore, after stemming process, placement start. These two words are available in the stored questions. Therefore, the placement generally start in July. The answer displayed on the screen properly. So the similarity score is perfectly 1. And placement starting month. If we are asking instead of date, the month anyway placement with start after stemming process. These two words are available. Therefore, placement generally start in July displayed on the screen, but the score of the similarity score 0.77. Anyway, it fits the correct one. Similarly, if the user asks placement started in dash month, here also started the ED removed from the stemming process, then placement start available in the previous query. Therefore, it will give us the correct answer. Placement generally start in July. Now the similarity score is 0.614. So when we type exit, it will give us goodbye. Now for your understanding purpose, I will run the same program. Watch the result. How do we give an input? Look at here. It will take time to run then. So now I am asking the question, placement eligibility. So this is the relevant answer. Okay. Next I will type the next question, placement start or when placement start. So placement generally start in July. If I am asking the question, placement starting date, now it will gives us a wrong answer because the stemming process not done here. So I exit from this program. Okay. Now it says goodbye now. Now I will run the next program. Watch the result now. So now placement eligibility. So now the answer is right. Now when placement start. Now the correct answer displayed. But I am asking placement starting date. Even though placement starting, uh, sorry, stating I typed placement date. So it will give us the correct answer. Started date of start date of placement. So all the questions differently asking, even though it will give us the correct answer. That is the example. The difference between the previous one without using stemming and bigrams. With using stemming and bigram, you can understand the difference between them. Okay, so the same program can be updated in this PPT. Thank you for watching.